Everything we have done so far in this section will be used in this video. In this video, we are going to learn how to sketch a polynomial function by using 5 steps. Graph f of x is equal to x cubed minus 9x. Step 1. Use the leading term to determine the end behavior. The leading term here is the term x cubed, where a, the coefficient, is 1, and the degree n is 3. A is 1, which is a positive number, and it's 3, which is an odd number. So with the coefficient being positive and the degree being odd, you should expect the graph to go up on the right and down on the left. Step 2, find the real zeros of f and their multiplicities and determine whether each zero will touch or cross the x-axis at an x-intercept. So x cubed minus 9x, to find the zeros, we let it equal to 0. We factor to solve. The GCF is x. So here we have x squared minus 9 is equal to 0. Factor again, x squared minus 9 as x plus 3, x minus 3, using difference of squares. And now let each factor be 0. So x is equal to 0, x plus 3 is equal to 0, or x minus 3 is equal to 0. Solve each of them. X is equal to 0, let's just bring it over. The second equation, x is equal to negative 3, and the last equation, x is equal to 3. Looking at this factor form and the exponent for each factor, I see that each of them has an exponent of 1. So that means each of these zeros here will have multiplicity equals 1. And that also means that the graph will cross through those x-intercepts. We'll cross through the x-intercept 0, 0, negative 3, 0, and 3, 0. Step 3, we want to find the y-intercepts. To find the y-intercept, we're going to substitute 0 in for x. So we're looking at 0 cubed minus 9 times 0, which is 0 minus 0, which equals 0. So the y-intercept is the point 0, 0. Step 4, test for symmetry if it's easy to apply. So f of x is x cubed minus 9x. F of negative x, you substitute negative x for x. And negative x cubed, still going to give you a negative value. And then 2 negatives here will give a positive. So comparing f of x and f of negative x, they are not the same. Therefore, the function is not even. So let's see if it's odd. To test to see if it's odd, we also need to find negative of f of x. So that's negative of x cubed minus 9x in parentheses. And if you were to distribute the negative, you get negative x cubed plus 9x. Now we compare f of negative x and negative f of x, and you can see that the two functions look exactly the same. So that means this function is odd and therefore is symmetric with respect to the origin. So that also means that when we graph, we can replace x with negative x and y with negative y. Step 5, plot more points between two consecutive x-intercepts to estimate the location of turning points. And here's a little fact. If the polynomial f of x has degree n, then its graph will have at most n minus 1 turning point. So if you look at the degree of this function is 3, since it's x cubed, then we should expect to have at most 2 turning points only. 3 minus 1 is 2. Now let's use all the information that we have here to sketch the graph. Let's plot all the x-intercepts, which are 0, 0, negative 3, 0, and 3, 0. So 0, 0, negative 3, 0, and 3, 0. And the y-intercept is the point 0, 0, which we already plotted that point. Now, in step 1, the end behavior is going to be up on the right and down on the left. We also know that at these zeros, the graph is going to cross through these zeros. And with it being up on the left, down on the right, we should expect the graph to look something like that. And it's crossing through the point 0, 0 as well. So there are two options, whether the graph could go in this direction or it can go in this direction. So the question is, which direction is it going to go? So let's say we have it go in this direction. Now, if it goes up this way, that means it can't really connect with this one, since the other arrow is going to go up. So let's try the other way. The other way has the potential, because if we can connect it somehow this way, then it makes sense. But to determine where these turning points might be, because it might go all the way up here before it turns, we are going to plot additional points. And that's where step 5 comes in. So we want to plot more points between two consecutive x-intercepts. So let's say we choose these two x-intercept, and let's just pick a value in between. So let's say we pick negative 1 and substitute it in the function. So x is equal to negative 1. So then we're looking at negative 1 cubed minus 9 times negative 1. That's negative 1 plus 9, and that will give us 8. So we have the point negative 1, 8 as one of the points on the graph. So negative 1, 8 will be this point right here. So we kind of have an idea of how high the graph might go. Next, I will use the point negative 2. We use another point. So x is equal to negative 2. So we're looking at negative 2 cubed minus 9 times negative 2. Negative 2 cubed should give you negative 8. Negative 9 times negative 2 is plus 18. So we should get 10 here. So another point is negative 2, 10. So it can go even higher. Negative 2, 10. It's about here. Now, since the function is odd, and that means it's symmetric with respect to the origin, I can also find a point that is symmetric on the other side. In that case, we are going to replace x with negative x, so replace negative 1 with 1, and y with negative y, so replace 8 with negative 8. So another point that is on this side would be 1, negative 8. It's going to be this point right here. And with this point being negative 2, 10, mapping it to the other side, since it's symmetric with respect to the origin, we can have the point 2, negative 10. So 2, negative 10 would be here. Now that should be pretty decent to draw our graph. So I'm going to redo this graph, make it look a little nicer. Perhaps we go about that high, go down, and we want it to cross through all the points that we drew. That will be the graph of the function x cubed minus 9x, approximately.